Welcome to our first micro lecture in one-dimensional calculus. Today we will prove two immediate consequences of the Bernoulli inequality. So let's start. The first statement is the following. If you have a real number a greater than 1, then there exists some natural number n such that a to the power of n is greater than every given real number. For our proof, we set x equal to a minus 1, then x is greater than 0 since a is greater than 1. If we now take a to the power of any natural number m, we get 1 plus x to the power of m, because if x is a minus 1, a equals 1 plus x. And due to the Bernoulli inequality, this is greater or equal to 1 plus n times x, since x is greater than 0 and therefore above all greater or equal to minus 1. Next, let b be a real number, then there exists a natural number n such that n times x is greater than b. Here we use the Archimedean property, which is applicable since x is greater than 0. As Bernoulli's inequality holds for every natural number m, we can identify m with n to get a to the power of n is greater or equal to 1 plus n times x, which is greater than 1 plus b, and this is certainly greater than b. So our proof is finished. For our second statement, we suppose a is a real number between 0 and 1. Then, for every epsilon greater than 0, there is a natural number n such that a to the power of n is smaller than epsilon, which means by exponentiation we can get a under every positive real number. So let's prove this. Suppose we have some positive epsilon and we introduce a dash as 1 over a, which is greater than 1. Then there exists an n such that a dash to the power of n is greater than 1 over epsilon. Here we use our first proposition with b equals 1 over epsilon. We conclude that a to the power of n, which is 1 over a dash to the power of n, is smaller than epsilon. Why? Since a dash to the power of epsilon and 1 over epsilon are both positive, we can take the inverse of both and reverse the greater than sign, which was to be proven. Thanks for watching and goodbye.